going on, guys? In this video we're gonna solve some systems of equations using the elimination method. Alright, here it is. Hey guys, so I already have a couple of videos up of solving systems of equations using two different methods. One was graphing and the other one was substitution. And this here is going to be the third one, that's called elimination. And in this video we'll do a few sort of introductory examples, and then I'll do another video of some tougher ones. But if you remember when we did substitution, substitution's really useful when one of your variables is already by itself, when it's already isolated. So as you can see here, none of the variables in either equation is by itself, and so these equations are in what we call standard form. And when your equations are set up this way, then elimination's usually the move. So how elimination works is you try to eliminate one of the variables. You try to get one of the variables to go away by either adding or subtracting your equations. So what I mean by that is, let's say I were to take this top equation and add it to the bottom equation. Well, then I would have 2x plus 2x, which is 4x, and then I'd have a positive 5y plus a positive 3y, which is 8y. And so adding these two equations doesn't get any variable to eliminate, to disappear. But if you notice, if I subtract these equations from each other, well, then I have 2x minus 2x, and that's 0. Anything minus itself is just 0. And then I have a positive 5y minus a positive 3y, and that's positive 2y. And then 25 minus 19 is 6. And so as you can see, by subtracting these equations from each other, I end up with a third equation where there's only one variable. And that's good because, first I'll simplify this. 0 plus 2y is just 2y. So this is good because we know how to solve equations that are in just one variable. We just have to get y by itself now, and to do that we divide both sides by 2. And so we see that y equals 3. And now that I know that y equals 3, then I can substitute the 3 in for y in either one of these equations. So I think the bottom one looks a little bit simpler, so I'm going to take 3 and substitute it in for y. So I'm going to copy down this equation here. 2x plus 3 times, instead of y, I'm going to do times 3, equals 19. And now this is an equation that is in one variable as well, so I can solve this equation for x now. So I'll simplify. So 2x plus 9 equals 19. And then I can subtract 9 from both sides. And so I get 2x equals 10. And then of course divide both sides by 2. And so x equals 5. And now I can put together my solution. So remember, the solution to a system of equations is an ordered pair. It's an xy coordinate pair, because the solution to the system is where the lines cross if you were to graph them. So x always goes first, that's 5. Y goes second, that's 3. So 5, 3 is my solution to the system. And you can always check this by substituting 5 in for x and 3 in for y, and then you can verify that the math checks out, and you do that for both equations. You make sure it works for both. Alright, but that's how it works. So step 1 is to figure out how to eliminate the variable. Do I add the equations together or do I subtract them? So in this case it was subtraction. Alright, so we'll move on to this one here. So you know, the last one was subtraction, so maybe this one's subtraction as well. So let's see if subtraction works. I'd have negative 2x minus 8x, which is negative 10x, so that doesn't eliminate. Negative 4y minus positive 4y is negative 8y. All right, so subtraction doesn't eliminate my x's or my y's, so now I'll try addition. All right, negative 2x plus 8x is positive 6x. So that doesn't eliminate, but hopefully the y's will. So now we have negative 4y plus positive 4y, and that is in fact 0. Negative 4y plus positive 4y is 0. And then negative 12 plus negative 24 is negative 36. All right, now I'll simplify. 6x plus 0 is just 6x. All right, and now I have a simple equation that is in one variable that I can solve. So I divide both sides by 6 here, and I see that x is going to equal negative 6. And now that I know what x is, I can substitute it in for x up here and solve for y. So I'll copy down this top equation. You could do the bottom one if you want. I'm going to do the top. So negative 2 times x, which is negative 6, minus 4y equals negative 12. All right, now I can simplify. Negative 2 times negative 6 is positive 12. All right, now I'm going to get y by itself, so I'll subtract 12 from both sides. So I get negative 4y equals negative 24. And then by dividing both sides by negative 4, I see that y is going to equal positive 6. And again, my solution is a coordinate pair. It's x comma y. So x in this case was negative 6. Y in this case was positive 6. And so negative 6 comma 6 is the solution to the system. Okay, we'll do one more. So again, we got to figure out whether adding or subtracting these will get a variable to eliminate. So let's try adding first. So 7x plus negative 4x is positive 3x. So that doesn't go away. Let's see if the y's do. Negative 7y plus negative 7y is negative 14y. All right, so addition's not going to cut it here. So what we want to do is subtract. 7x minus negative 4x, that's the same thing as saying 7x plus 4x, which is going to be 11x. All right, and then negative 7y minus negative 7y is the same thing as saying negative 7y plus 7y, which is 0. All right, anything minus itself is 0. All right, and then we subtract 7 minus negative 26, and that is the same thing as saying 7 plus 26, which is going to be 33. Simplify. And then we can divide both sides by 11 here. You see that x equals 3. And now that we know what x equals, we can go ahead and substitute it in for x. So I'll pick the top equation. 7 times 3 minus 7y equals 7. And that's going to be 21 minus 7y equals 7. And then I can subtract 21 from both sides here. So I get negative 7y equals 7 minus 14, which is negative 4, or sorry, 7 minus 21, which is negative 14. And then we divide both sides by negative 7. And so y equals positive 2, because negative 14 divided by negative 7 is positive 2. And so my solution to the system is positive 3, x always goes first, comma 2. All right. And then before I go here, I want to you might be asking yourself, why are we allowed to do this in the first place? Why are we allowed to subtract an equation from another or add an equation to another? And you need to remember that you're allowed to do anything to an equation as long as you do it to both sides. So if you see this top equation here, right, I can do anything I want to this top equation as long as I do it to both sides. So I'm subtracting this from this, and I'm subtracting this from this. So it might look like you're doing two different things to the two sides, but remember, these two things are equal, right? These two expressions are equal to each other. So if I take away this from this, I am doing the same thing. I'm taking away the same amount as subtracting negative 26 from 7 would be, because these two are the same thing. Okay? So in the next video, we'll do some more difficult examples. But with that said, it's been demonstrated.